Hi folks, in this video we are going to continue our discussion on R programming with an example to represent ROC and AUC. You can refer to my previous videos on ROC and AUC and also the RStudio installation in case if you want to get a background of it. So let's get started. So to start with, we will assume an example. Let's consider a set of 100 candidates preparing for a competitive examination, and we will be plotting ROC and AUC chart with number of hours they spent learning versus the examination result, either pass or fail. Using ROC, we will compare different thresholds and find the best threshold which gives a better result out of the confusion matrix, and AUC will determine the better ML algorithm which we are using. So for this illustration, we will be using linear regression and random forest algorithm. To execute these in R, let's first import the libraries. So this is the library. PROC is a library for ROC, and in case if it doesn't comes with this package, you can install it. So let's open RStudio and install this package. So if this package is not available, it will install the binary. So the binaries are available under this directory, and also we will install for random forest. Right. So once we have installed these packages, we can use these libraries, and we can execute here in R. Right. So now we can make use of the functions available in these libraries. So the next step is to we are going to generate 100 numbers, 100 samples for the person and their number of hours spent in learning. So for that, we are setting the seed to 420 here. That gives better result for the random number, and also we are passing 100 to the samples which we are going to use here. And in the next step, what we are doing is consider a mean of 50 and standard deviation of 12. This is for the learning hours. Let's take the average learning hours as 50 for a person and the standard deviation of 12. So basically we are trying to assign a random number for the learning hours based on the mean and standard deviation using random normal distribution, and we are sorting that series of numbers and passing on to a variable elearn. So when we execute these steps in R, we will get variables assigned like this. So elearn will be the variable which is holding value of 100. There will be 100 values each for each person. There are different randomly generated value for the learning hours, and the number of sample has been assigned as 100. In the next step, we are going to determine if for those 100 numbers we are at a random, we are going to determine if it is a pass or a fail. So for that, we are going to do these steps. We use the rank function, and for the list of numbers which we generated now, we are going to rank it. So the least number will be assigned a rank of 1, the next least number will be assigned a rank of 2, and the largest number will be assigned a rank of 100. So we are going to divide that by the number of samples, that is 100, and compare it with the random number of 0 to 1, and based on that we will store the result into pass. We'll determine either it's a yes or no if it passed this condition, and store that result into the variable called pass. So what happens, we are classifying into two buckets, either that candidate is pass or fail, and we are assigning a number like 1 for pass and 0 for fail. So when we execute this step, as you can see, we are printing the result here in the console itself. For these 100 numbers, either 0 or 1 has been assigned based on the calculation. So 0 indicates a fail and 1 indicates a pass. So next we are going to plot a simple graph with these variables of elearn and the pass, which we obtained in the previous step. So when we use this in RStudio, we get a result here. So you can see the chart with elearn as x-axis and the pass as y-axis. These are the data points where we represent the fail, and these are the data points we are representing the pass based on the learning hours. This is a simple graph, and let's fit this data into a logistic regression where we are using a generalized linear model, this function GLM, and in order to draw a line we are using the lines function and use the GLM fitted values. So as you can see, a line has been drawn for it been represented in a logistic regression. And now we are going to draw ROC and AUC using the library which we imported. So ROC is a function, and we are going to pass the variable called pass and the GLM, the linear regression model which we are going to use here, plot equal to true. So on executing this step, we get the ROC graph here. So now the graph is not actually in a perfect square, so we are going to set it as square. And now execute it. So now you can see it's a perfect square, and ROC has been represented for the different data points which we considered, and these are the thresholds, and now we can determine the best threshold. So in the next step, there are few things to do, like the axis is not proper here. So as you see, the axis is reversed, it like from 1 to 0 instead of 0 to 1. So we can do 1 minus specificity to represent properly. So when I execute, when I set this function legacy axis equal to true, it reverses the variable 1 minus specificity, and we can rename these as well and define the variables in the form of percentage. When I execute this, I am setting the percentage as true, and I'm setting renaming the x-axis and y-axis, so that redefines that in the chart with percent. It depicts in percentage and renames the x-axis and y-axis. So I'm executing this step where I'm storing this ROC data into ROC.information, and we are now going to access the individual information inside using a data frame. So we store it in a variable called ROC.info, and using that ROC.info we are going to access the sensitivity and specificity data and also the threshold. So here, as you can see, these numbers are inside the data, and we are going to extract these information out of these variables, and also the thresholds have been defined inside the ROC inbuilt function. So using this data frame, what I'm going to do is extract that information into a data frame. And now so here I am doing some manipulations, like I'm representing into true positive percentage, so I multiplied this with 100, and the false positive percentage multiplied by 100. And also we are going to extract the threshold. So head.roc will actually extract as the top portion. So head of ROC, the data frame. So this extracts information which represents the upper left, upper right corner. So this line has been extracted, and as you can see, minus infinity, this refers to the last data point, and at this point all the data or all the person are represented as pass. So even the true positives are represented as pass, and even the false positive are represented as pass. And when I take the tail value from the lower left, so this represents a infinity value from this frame, and all the values which have been considered as fail. So even the true positive percentage and even the false positive both are considered as fail with this threshold. So these are the extreme thresholds, and with this we are going to obtain, we see the percentage somewhere here, which may give us a better threshold. So in order to take that, we are going to consider the 60 to 80 percentage of this graph, and that is what we are doing in the next step. So we are trying to extract threshold in that and represent that in a ROC, and we are going to use this function. So now we have extracted just the 60 to 80 percentage of the threshold limit, and we have arrived at a AUC. We have represented ROC with the best threshold, as well as we have arrived at a AUC for that linear regression, which we linear regression model which we plotted. So now we are going to fit the data for the random forest. And let's draw a ROC curve for it. So this is the ROC curve for random forest. Initially we did for the linear regression, and now this is for random forest. And as you see, the AUC for this is calculated as 79.3%. And actually we can compare both random forest and linear regression in a single chart. And the blue indicates logistic regression, and green indicates a random forest with their percentage which have been hidden here. Alright, so here from this graph we can infer, like, we have identified the better threshold from the ROC curve, and also we represented in both the models using logistic regression as well as random forest, and we have also calculated the AUC for both logistic regression and random forest, and have determined which algorithm works best. As you can see, logistic regression works best. That gives better results. So the final chart looks like this, and you can refer to my GitHub repository to get the full code, and you can work on your own. So that's it for the video today. We will cover the Python and the remaining topics in the next video. Oh, thank you very much. Take care.